Good morning, students. I hope all you are safe. Just let us recall the last class. Last maths class, we learnt RGA, how to find out RGA using cofactor. See, in this class, a new topic, that is inverse of a square matrix. See, if it is a square matrix, only we can find it out inverse. See, A into B equal to B into A equal to IN. It's I is identity matrix or unit matrix. We know that what is identity matrix, right? Now, let A be a square matrix of order n. The same B is a square matrix of order n. And if we have AB equal to BA is equal to IN, then we can say B is the inverse of A or A is the inverse of B. Either B is the inverse of A or A is the inverse of B. See here, if we are getting AB equal to BA is equal to I2, then what is the meaning? Both it is a square matrix of order 2. So, if order 2 and if you are getting AB equal to BA equal to I2, then we will be able to say that A is the inverse of B or B is the inverse of A. If it is I3, we may get that as 3. What is I2? I2 identity matrix of order 2, that is 1 0 0 1. If it is I3, 1 0 0. 0 1 0 0 0 1. Let's learn a theorem. That's theorem 1.2. If A is a square matrix and has an inverse, then it is unique. If a square matrix has an inverse, then it is unique. Okay, let us learn the proof. So I have taken, okay, we can take a square matrix A. Let A be a square matrix of order n, such that inverse of A exists. Inverse also can be able to find out, we have taken. So we are supposed to prove that is unique. So let us prove we can take that if A has 2 inverse, what happens? We will try to find it out. Okay, suppose let there be 2 inverses, B and C for A. For A, now we have taken 2 inverses, that is B and C. If B is the inverse of A, then what happens? AB equal to BA equal to IN. Also, if C is the inverse of A, what happens? AZ equal to CA is equal to IN. So, both we can put it as an equation. So, now we are supposed to prove A has only one inverse. Okay, I am taking C. We know that when we multiply a matrix with identity or unit matrix, we will be getting the same matrix. So, I have written C as C into IN, because here we have taken of order n. Now, we know that IN equal to BA as well as IN equal to AB. As for our proof, I am taking this AB, C into AB. Since matrix is multiplication is associative, what is that associative? A into BC is equal to AB into C, right? Associative property. So, I can change the bracket. See, I have put the bracket CA into B. Now, CA, we have put at equation 1, CA is equal to IN. Now, IN into B means what? Identity matrix into B, we will be getting the same B. So, we are getting C is equal to B. So, then what is the meaning? Inverse, for a matrix, we will be getting only one inverse. Hence, inverse of A is unique. Inverse of A is unique. Say, this inverse can be inverse of A is denoted as A inverse. Already we learned AB equal to BA is equal to IN. Therefore, this inverse of A inverse, I can write it as A into A inverse is equal to A inverse into A is equal to IN. A into A inverse equal to A inverse into A is equal to IN. So listen, now we have learnt that inverse of a matrix is unique. Now how to find out inverse? What is the formula for A inverse? In order to that, theorem 1.1 in the last class we learned. See, A into adj A is equal to adj A into A is equal to determinant A into IN. I hope we did a problem also. First example also. A into adj A equal to adj A into A is equal to determinant A into IN. Okay, I need only IN. What I can do? Divide all the terms by determinant A. See, as for our convenient, I am writing it in such a way. 1 by determinant A into adj A equal to 1 by determinant A into adj A into A is equal to IN. So if we are writing the same inverse formula, I may get A into A inverse equal to A inverse into A is equal to IN. Am I right? So this is inverse of A is 1 by determinant A into adj A. So I can write A inverse is equal to 1 by determinant A into adj A. So what is the formula to find out inverse? Inverse of A is that, or A inverse is equal to 1 by determinant A into adj A. Now determinant A is in denominator. Denominator cannot be equal to 0. So the main condition to find out the inverses or to exist is determinant A should not be equal to 0. If determinant A is equal to, then adj A divided by 0, any number divided by 0 is infinity. So A inverse does not exist. If determinant A equal to 0, A inverse does not exist. This we have learned, or if you are not remembering, let me remind you that determinant A equal to 0 implies A is singular matrix. Last year you might have learned. If you are not remembering, just determinant A equal to 0 means it is understood A is singular matrix. If so, determinant A not equal to 0 we need. If A is a non-singular matrix, A is a non-singular matrix, then we can able to say that A inverse exists. A inverse exists. So the formula to find out inverse is A inverse is equal to 1 by determinant A into adj A. What's the formula to find out A inverse? 1 by determinant A into. Okay, now shall we do a problem? Let's example 1.2. If A equal to matrix A, B, C, D is non-singular, find A inverse. Find A inverse. So this is given. It is A is a non-singular matrix. So we are very sure that A inverse exists. Anyway, we can find it out. Determinant A first. Determinant A is equal to determinant A, B, C, D. How to find it out? The determinant, we know the product of the main diagonal minus the other diagonal, that is AD minus CB. Since they have given it is non-singular, this value is not equal to 0. Therefore, we can say A inverse exists. And what is the formula to find out A inverse? Just before we learned, that is 1 by determinant A into arch A. So determinant A we have found out. Now we need to find it out what is arch A. Actually this is a 2 by 2 matrix, right? Last class we learned how to find out the arch A for 3 by 3 matrix. What is that arch A? Arch A formula, first we have to find out cofactor. What is that cofactor? Minus 1 power I plus j into Mij. Mij is minor. Mij is minor. So here to find it out, make it very easy. Aij equal to, we can put the symbol first, plus minus minus plus. If it is for 3 by 3 matrix, we might have put plus minus plus minus plus minus plus minus plus. Is it not? That's for 3 by 3 matrix. If it is 2 by 2 matrix, plus minus minus plus. Why? I plus j. The position of this is A11. 1 plus 1 is 2, even number, positive. This position may be 1, 2. So 1 plus 2 is 3, negative. This position will be maybe A21. 2 plus 1, 3, odd. So it is negative. This is 2, 2. 2 plus 2 is 4. So we might have got it as positive. Actually here Mij, how we will be finding out? After this, leaving the corresponding row and column. If we leave that corresponding row and column, the element is D. Here, for this position, leaving the corresponding row and column, the element is C. Here, B, and for this position, leaving the row and column, this is A. Now we can find it out. Arch A. We know arch A is equal to Aij the whole transpose, that is D minus C minus B A the whole transpose. So we may get it. Transpose means what is the meaning? Exchanging row and column. So D minus C minus B A. It's very simple, right? Now you can put this as equation number 1. So equation 1 implies A inverse is equal to 1 by determinant A. What's determinant A? We have got it. AD minus CB into arch A, that is D minus B minus C. Have you all understood this? Say one more easy method. What shortcut is there to find out the arch A of 2 by 2 matrix? Say, let me write it here itself. For a 2 by 2 matrix, see, arch A, sorry, capital A, arch A is equal to, just you can exchange the main diagonal, AD. So you can write it DA. This same element, just change the symbol. B means minus B and this is C means minus C. Check our answer, see, D minus B minus C. You need not to do all these steps. For 2 by 2 matrix, directly you can write the answer, exchange the main diagonal. This A, D, you can exchange it. This, just change the symbol. Okay. Shall we do? If you have a doubt, we can do one more problem. See, just an example. Capital A is equal to, let me write 1, minus 2, 3, 4. Okay. Arch A. As I said, first exchange the diagonal. 4, 1. This same element, change the symbol. Minus 2 means we may get plus 2. Plus 3 means we will be getting minus 3. This is applicable only for 2 by 2 matrix. Okay, not 3 by 3. It will be applicable only for 2 by 2. 3 by 3 we have to do it using that formula method. Right? Have you all understood regarding that A inverse of 2 by 2 matrix? Okay, now we can move to the next example, that is how to find out the inverse for 3 by 3 matrix. Okay, 3 by 3 matrix. Okay, let me write that example 1.3. Find the inverse of the matrix two minus 1 minus 5 3 1 minus 3 2 3. Okay, for this we have to find out the inverse. This is inverse of matrix using, this is a 3 by 3 matrix. So since no name is given, we can take it. Let A is equal to matrix 2 minus 1 3 minus 5 3 1 minus 3 2 3. Okay, so first we should check it whether it is a singular matrix or not singular matrix. For that we will find it out. Determinant A. Determinant A is equal to determinant 2 minus 1 3 minus 5 3 1 minus 3 2 3. So determinant we know to find it out, right? First we will be writing 2 into, leave that row and column. Now the determinant of these 4 values. Main diagonal minus the other diagonal. So 3 into 3 9 minus 2 into 1 is 2. Second value when we write, we have to give the symbol minus. Check the number, there we have a minus, so we will put it in the bracket. Now corresponding column and row we have to eliminate. So remaining these 2 values and these 2. So main diagonal minus 5 into 3 minus 15 minus 3 into 1 is minus 3. Since we have a minus here, it will become plus 3. Then the last value, that is plus 3 into, leaving the row and column, determinant of these 4 values. Minus 5 into 2 minus 10 minus 3 into 3 is minus 9. We will be getting, that is plus 9. Okay, now 2 into 9 minus 2 7. This is minus into minus, plus 1 minus 15 plus 3 minus 12 plus 3 into minus 10 plus 1, that's minus 1. So that is 14 minus 12 minus 3, or 14 minus 12 minus 3 is minus 15, which is equal to minus 1. This is not equal to 0. Therefore, A inverse exists. So we will be able to find it out. A. So we have found out determinant A is equal to minus 1. Now shall we write the formula? A inverse is equal to, we know that 1 by determinant A into HA. 1 by determinant A into HA. Let me keep it as equation number 1 because we need to find out HA. In order to find out HA, we need to find out first AIJ. So that, as I said, we can put plus, minus, plus, then minus, plus, minus, plus, minus, plus. Okay, using this. For the first position, leaving the row and column, the remaining values. So that is 3, 1, 2, 3. And for this position, leave that row and column. Remaining 4 values, minus 5, 1, minus 3, 3. And here, leave that corresponding row and column. That is determinant minus 5, 3, 3, 2. See, for the second position, this is minus. For this element, leave that corresponding row and column. We will be getting that minus 1, 3, 2, 3. And for the middle position, 2, 3, minus 3, 3. And for this place, 2, minus 1, minus 3, 2. For this position, what we should do? Corresponding row and column, we have to eliminate. So the remaining value, minus 1, 3, 3, 1. Same way, we have to find out for this position. So 2, 3, minus 5, 1. And for here, this 4 values, 2, minus 1, minus 5, 3. Shall we do it now? Simplify. See, main diagonal minus other diagonal. 9 minus 2 minus, this is minus 15 minus 3 into 1 is minus 3, it will become plus 3. This is minus 10 minus 9. Yeah, already we have a minus. Minus 1 into 3, minus 3, minus 2 into 3 is 6. This is 6 minus 9, it will become plus 9. Minus 2 into 2, 4, minus into minus plus 3 into 1 is 3. This is minus 1 minus 9. Minus of 2 minus 5 into 3 is minus 15, it will become plus 15. This is 6 minus 5. Now we can write the answer. This is 7 minus 15 plus 3 is minus 12. Since we have a minus outside, it will become plus 12. And this is minus 10 and minus 9. Sorry, this is minus 10 plus 9. The answer is minus 1. And this is minus 3 minus 6 is minus 9. Since outside a minus is there, this is plus 9. 6 plus 9, 15. My 4 minus 3 is 1 and this is minus 1. Minus 10. This is 17. Outside minus is there, minus 17. 6 minus 5 is 1. So we have found out Aij. Now we can find it out Aj. We know that Aj is equal to Aij the whole transverse. Transverse means what is that? Writing the row and exchanging the row and column. So 7, 12 minus 1. And this is 9, 15 minus 1. And this is minus 10 minus 17, 1. Now we can write it in that formula. Equation 1 implies, what is that? A inverse is equal to 1 by determinant A into Aj. 1 by determinant A into Aj. We know that determinant A is minus 1. This is 7, 9 minus 10. 12, 15 minus 17. Minus 1 and plus 1. So we know that 1 by minus 1 is minus 1. So we can, when we give it inside, all will be changed. Minus 7, minus 9, plus 10, minus 12, minus 15, 17, 1, minus 1. Thus, we have got that A inverse. So, listen. Now we have learned how to find out adjoint of 2 by 2 matrix, how to find out adjoint of 3 by 3 matrix. Same, how to find out the inverse for 2 by 2 matrix and 3 by 3 matrix. So, these are the work done for you. See the question, find the adjoint of the following Aj. 3 matrices are given, you have to find out the adjoint. And the second one is find the inverse of, inverse if it exists. Why it is given? If the determinant value is equal to 0, A inverse does not exist. That is why first you should check whether the determinant value is not equal to 0 or not. If it is not equal to 0, you have to find out the inverse for the following. There are also 3 problems are given. And this one actually I gave in the last class, but the question was not given. So if A is equal to, the 2 by 2 matrix is given, verify A into Aj equal to Aj equal to determinant A into I2. So determinant A, so when we find out it is easy. Actually this is 24 minus 20. Determinant A you will be getting 4. So this answer you can easily verify. A into RGA, you should get it 4004. Then your answer will be correct. See, the answers of first and second problems I have given to check your answers. See, I had a small issue that in the last class the video was not clear. I hope this video it will be clear. And if there is any doubt or something, you can message me. Okay, thank you students. See you in the next class. Bye-bye.